Okay, I'm going to work through these problems as quick as possible so you can use this as a guide. The twice differentiable function f is defined for all real numbers and satisfies the following conditions. Alright, so twice differentiable means the function is continuous and that it's going to be very smooth, so that limit exists in the first derivative. And to be twice differentiable means that first derivative also must be continuous, and then the limit exists, it's very smooth for that second derivative as well. So the first derivative is also smooth. Okay. A. The function g is given by g of x equals e to the a of x plus f of x for all real numbers where a is a constant. Find g prime of 0 and g double prime of 0 in terms of a. Show the work that leads to the answer. All right. So g of x equals a to the x plus f of x. So the first derivative would be e to the ax times the derivative of ax, which would be a is a constant, plus the derivative of f of x, which is f prime of x. And if I were going by the chain rule, then I would say times 1. All right, if we clean this up, it would be a times e to the ax power plus f prime of x. And the second derivative would be the derivative of that, which would be a is a constant, so it comes along, times the derivative of e to the ax would be e to the ax times a again, plus the derivative of f prime, which would be f double prime of x. And again, if I were practicing the chain rule, the derivative of x would be times 1. And if we clean this up, this would be a squared e to the ax plus f double prime of x. There we go. Find g prime of 0 and g double prime of 0 in terms of a. All right. So g prime of 0 just means we're going to plug in 0 into this function. So for everywhere there's an x. So it'd be a times e to the a times 0 plus the f prime of 0. Well, that would be a times e to the 0 plus f prime of 0. And I believe they gave us values. F prime of 0 is negative 4. So anything that's 0 powers 1, so that's just a times 1 plus negative 4. So a minus 4. G prime of 0. G double prime of 0 would be a squared times e to the a times 0 plus f double prime of 0. And again, there's a value up there for that. This would be a squared times e of 0 plus f double prime of 0. And f double prime of 0 is 3. So a squared times 1 plus 3, which would be a squared plus 3 for the second derivative. What do we answer? Should the work leads to your answer? Okay, got it. The function h is given by h of x equals cosine of kx times f of x for all real numbers where k is constant. Find h prime of x and write an equation for the line tangent to the graph of h. All right, well, let's find that derivative first. Cosine kx times f of x. Just make sure I wrote this down right. Okay, k is a constant. So the derivative, well, we got the values. Let's see. X is 0. We're going to find the tangent line. So we need to know x is 0. We need to know the y value. And we're going to need to know the slope, which of course will be h prime of 0. All right. So let's do the y of 0. So that would be the h of 0, which would be the cosine of k times 0 times the f of 0, which would be the cosine of 0 times the f of 0, which in the f of 0 should be up here. F of 0 is 2. Cosine of 0 is the x value at 0, which is 1, times 2, so 2. All right, y value is 2. Now the derivative. Looks like a product rule to me with a chain rule built in. So h prime of x is equal to derivative cosine, negative sine of k times x times the derivative of k times x, which is k, times f of x the way that it is, plus cosine of kx stays the same, times the derivative of f of x. And I could put times 1 if we're doing the chain rule. All right, and then we're supposed to plug in 0 for all of these. So that's what it's telling us here. So we can get that slope. And that would be negative sine of k times 0 times k times f of 0 plus the cosine of k times 0 times f prime of 0 times 1. All right, well, negative sine of 0 times k times f of 0, which is 2 from earlier, plus the cosine of 0 times f prime of 0, I want to say it's negative 4, times 1. That's negative 1 times sine of 0. Well, sine of 0 is 0. So negative 1 times 0 times k times 2 just means 0. Plus cosine of 0 is 1 times negative 4 times 1, which is just negative 4. So it's fair to say the slope is just negative 4. Well, we got all the information we need. Y equals negative 4, x minus 0 plus 2, the equation of our tangent line. All right, I think we've answered everything. So no calculator. Find the derivative of x times sine of x. Well, that would be the derivative of x is 1 times sine of x the way that it is, plus x the way that it is times derivative of sine of x, which is the cosine of x. So sine of x plus x cosine of x, or b. Find f prime of 1. Well, let's find the derivative. F prime equals 7 minus derivative of 3 is 0 plus x, derivative of x is 1 on top. So natural log is whatever it is on the bottom, its derivative on top. And we're plugging in 1, so this is just going to be 7 minus 0 plus 1 over 1, which 8. Chain rule, 5 x to the third minus cosine of x to the fourth power times derivative of the inside, which is 3x squared minus the cosine of x is a negative sine of x. So that ends up being a plus. And Here we are. E. F of x equals the square root of x squared minus 4. G of x equals 3x plus 2. Then the derivative of f of g of x at x equals 3 is, all right, well, according to the chain rule, the derivative would be f prime of g of x times g prime of x. And so if we were putting in values, then at x equals 3, this would be whatever f prime of g of 3 is times g prime of 3. All right, well, let's find those values. The g of 3 is equal to 3 times 3 minus 2, which is 7. And the g prime of x is 3. So the g prime of 3 is just 3. All right, so we got that value. We're going to need it. We've got that value 7. We're going to need it. We need the derivative of f of x. So f of x is equal to x squared minus 4 to the 1/2 power. So its derivative would be 1/2 times x squared minus 4 to the negative 1/2 times the derivative of the inside, which is 2x. So cleaning this up, this would just be 1/2 and 2x over the square root of x squared minus 4. Okay, well, let's find this out. So remember, we're doing this. So f prime of g of 3. Well, the g of 3 is 7. So it's f prime of 7 that we're looking for. And I guess we can make a note of that. F prime of the g of 3 is 7 times g prime of 3, which is 3. So it's f prime of 7 times 3. Okay, well, let's find out what 7 is when we plug it in over here. So f prime of 7 equals 7 divided by 7 squared is 49 minus 4, and 49 minus 4 is 45. So it's square root of 45. The only thing I'd concern about is that 45 is 9 times 5, and the square root of 9 is 3. So this would be 7 over 3 square roots of 5. All right, let's use that value and put it in. So 7 over 3 square roots of 5 times 3, and that'd be 3 over 1, and we can cross off 3. So it looks like the answer is 7 over the square root of 5. Is that a choice? Hey, there we go. Could have also done the composition of functions, just plug that in, square it, and done all the derivative of what we had. And what I mean by that is g of x is 3x minus 2. So if I were to erase all of this mess, could have also just done it by plugging it in. Said that f of g of x, and probably most people would find this easier, would be 3x minus 2 squared minus 4. And if we square that out, 9x squared, 3 times 2 is 6, times 2 is 12x, plus 4, minus 4. So this would be 9x squared minus 12x to the 1/2 power. And the f prime of g of x, or this new function, let's just call it h of x. So when I go to find h prime, the new composition, be 1/2 times 9x squared minus 12x to the negative 1/2 times 18x minus 12. And if we plug in 3 here, uh, we get it. Let's see. Let me go ahead and take half of that. So 9x minus 6 over top of the square root of 9x squared minus 12x. I took half of this. You can do that. It's the first power, so we can actually simplify that. 9x minus 6. We're going to plug in 3. So if we plug in 3 here, that would be 27 minus 6, 21, over the square root of 9 times 9 is 81. 81 minus 12 times 3 is 36. I think it's 45. Yep. And again, that would be 3 square roots of 5. And 3 goes in that 7 times, so 7 over square root of 5. Maybe that was easier. To each their own. All right, the function f is defined by this. At what points do we have property that the line tangent has a slope? So we're going to set the derivative equal to 1/2, and that's a quotient rule. So f prime will be equal to the derivative of the top, 1 times x plus 2 the way that it is, minus x, the derivative of the bottom is 1, all over the denominator squared, x plus 2 squared. Let's simplify the numerator. So we'd get 1 times x plus 2 is x plus 2 minus x. So we just have 2 over x plus 2 squared. And we want to know where it has a slope of 1/2. Well, there's a slope. So we'll set that equal to 1/2. Cross multiply if we're going to solve this equation. Or you could just say we want to get a common denominator. This side needs a 2, top and bottom. This side needs an x plus 2 squared, top and bottom. Same idea. We're cross multiplying, right? 2 times 2, 4. Once the denominators are the same, we work out the numerators. 1 times x plus 2 squared, which would just be x plus 2 squared. I'm going to take the square root. Anytime you take a square root, you better write plus or minus. Square root of 4 is 2. X plus 2. We're going to subtract 2 from 2. And we're going to subtract 2 from negative 2. So we'll get x equals 2 minus 2 is 0. And negative 2 minus 2 is negative 4. So we're 0, negative 4. It looks like it's these values. And if we plug those in, 0, we get 0 over top of 0 plus 2, which is just 0. And negative 4, because it does say the coordinates, right? Find the points, x and y. If we plug in negative 4 over negative 4 plus 2, negative 4 over negative 2 equals 2. So, yep, see it is. Find the inverse derivative at g prime of 1. Okay. Well, first thing is, let g be the inverse. So I think we did this in class at one time. If g is the inverse, remember that's a y value right there. So making a note, at f of x must equal y for some x value, because they're inverses. So in this case, f of x, that function must equal 1. So we come over here. 2x plus 1 to the third power must equal 1. And we're going to solve that. We'll take the cubed root of both sides. All we're going to do is show that it's 0, but because they don't give you that value otherwise. 1 to any power is just 1. But this will just be 2x plus 1. We don't do plus or minus on an odd root. That's not the same as if it's a fourth root we would. Subtract 1. 2x equals 0, and divide by 2. Of course, x equals 0. Not surprised, all right, that the g of 1 is equal to 0. So that could be useful for us. We know their inverses. So the derivative, the way we had it written in class, was, so g equals the inverse of f of x. Okay, so the way we did it in class, the little formula we had, the inverse's derivative was 1 over top of the regular function over top of the inverse of f of x. That was our formula that we had for that. And there it goes. I guess we're just putting in these values. I feel like I'm missing something here. That's it. To the outside. Oh, f prime. Normal derivatives at the inverse's value. That's what I'm missing. Yeah, because it was the chain rule. All right. So f prime and the inverse of x, which was the g of 1. So it's the g of 1, which is 0. So flipping x and y. So it's whatever f prime of 0 is. And f prime, never found it. Better go find it. F prime is 3 times 2x plus 1 to the second power times 2. All right. And then we're plugging in 0. So it's right here. That's 6 times 2x plus 1 to the second power. And we're plugging in 0. So 2 times 0 is 0. Plus 1 to the second power, which is just going to be 1. So all this is just 1 over top of 6. There you go. All right. This just says, this is definition of the derivative. F of x is equal to the natural log of the sine of x. So this would be the sine of x on bottom. And the derivative sine of x would go on top. So cosine of x. And cosine of x over sine of x, just cotangent of x. This is the alternate definition, but again, f of x equals the sine of x, and really what they're asking us for is what is f prime pi over 2. So f prime is cosine of x, and f prime would be cosine at pi over 2, and pi over 2 is up at the top. That's 0. All right. Yeah, it makes sense too. If you think about the graph, sine of x at 0, 0, and that pi is back at 0, and pi over 2 is a maximum at 1, and of course the slope is 0 at a maximum. So there you go. The equation of the normal lines of the graph of y equals e to the 2x when derivative is 2 is the equation of the normal line. All right, just find the equation of the normal line when the derivative is 2. So we need the x and y values. It's got to be this negative a half, because if we're talking normal line. Let's just find the derivative. So the derivative of e to the 2x, y prime is e to the 2x times 2, which would be just 2 e to the 2x. And we're going to set that equal to 2, because that's what it said, right? The derivative is equal to 2. Because I need the x value. We got the slope. So we divide both sides by 2. E to the 2x is equal to 1. Change it to logarithmic form. So this would be log with a base of e, which is natural log of 1, is equal to 2x. Just logarithmic form. And that's 0 is equal to 2x. So x is 0. Okay, well, if x is 0, then y is equal to e to the 2 times 0, which is just e to the 0, which is 1. So now we have values. X is 0, y is 1, and we've got the slope of the tangent line. That's what a derivative is. So the tangent line would go y equals 2, x minus 0, plus 1, but we want the normal line. So negative 1/2, x minus 0, plus 1. And that is this one. If f of x equals 5 times cosine squared pi minus x, then f prime, all right, first of all, let's write this down so that we can do the chain rule properly. Cosine of pi minus x squared. And then the derivative would be, well, 5 times 2. So f prime would be 10 times the cosine of pi minus x to the first power times negative sine of pi minus x. So we did the derivative of the outside, we did the derivative of that, times the derivative of pi minus x, which is be negative 1. And if we put all that together, we got a negative 1, 10. So it should just be 10 times the cosine of pi minus x times the sine of pi minus x. And we're going to put in pi over 2, so we're taking away 1/2 of pi. So when it's all said and done, plugging in that value, 10, we're taking away pi over 2, so we're taking away 1/2. So we'll end up with 1/2 pi over 2 times sine of pi over 2. And cosine of pi over 2 is 0. Sine of pi over 2 is 1. 0. For what values of k does the graph have a normal line whose slope? Okay, so find the derivative. If we're saying normal line, then that means the tangent line is going to be the opposite reciprocal. So I would flip it, make it a lot easier. Just put the derivative equal to 5 when x is 1. All right. So key here, another one, x is 1. So let's find the derivative. So g prime is going to be k is a constant times e to the 2x times the derivative of 2x, which is 2, plus the derivative of 3, which is 3x, which is 3. All right. So x is 1, and we're setting this equal to 5. So if x is 1, then that means that we'll have k times e to the 2 times 1, which is 2, times 2 plus 3 is equal to 5. That's the last problem on the page, of course not. All right, I'll clean that up. So 2k e to the second, 2k e to the second plus 3 is equal to 5. We're going to subtract 3 from both sides. 2k e to the second is equal to 2. Divide by 2. K e to the second is equal to 1. Divide by e to the second. K is 1 over e to the second. There we go. Find the derivative of this. All right, the derivative of tangent is, the derivatives that, they already gave us the derivative. Never mind. I'm just making sure we know. So sine of 2x divided by cosine of 2x. That would be the tangent of 2x. That's the derivative. We're putting in pi over 6, so this would just be the sine of um, pi over 3 and cosine of pi over 3. Well, pi over 3, I'm always doing unit circles, so that'd be 180 over pi, so the pi's cancel out, and this would be 60 degrees. 60 degrees. So 60 degrees would be up here, so that would be 1/2, that's the shorter value, and then square root of 3 over 2 is the longer value. So it's 1/2 the sine, sorry, cosine, square root of 3 over 2 sine divided by 1/2, which means times the reciprocal 2 over 1, square root of 3. All right, calculator. I got my calculator out. Y equals e to the tangent of x minus 2 crosses the x-axis at one point in the interval 0 to 1. What is the slope of the graph at this point? All right, well, I'm doing the whole thing on the calculator, so follow along, I suppose. So e to the tangent of x. Okay, so we've got this typed in. I'm going to change my window. I just want to go from 0 to 1. That's what they told us. And we want to know where it crosses the x-axis. So you don't need to go crazy on your y. You just need to have 0. So we can find an x-intercept there. And I'm pressing graph. See what we look. There's the 1 value. So we find it. Second and trace and 0. And left bound. That looks left. Just want to surround that spot. Oh, I went too far. There we go. Right bound. Guess. I don't play guessing yet. All right, 0.606. Okay, my calculator is going to remember that value. So if I go to the regular screen now, and I go alpha window, and I choose inderiv, we'll find the derivative with respect to x of our function. I can go alpha and trace. Nope. Back there. Alpha trace. There we go. Oh, rats. Easier to press buttons with a calculator than it is on the computer. But alpha trace, I can type in y1 because that'll give me that equation. And I can put in 0.606, but I can also just put in x because it should know it. Oh, I'm a little worried because I pressed trace that x is not that 0.606. I need to test it. Okay, it is, so we're good. 2.96 is my value, and so 2.96, what is the slope? 2.96, and I'm sure it's just a rounding thing and maybe I'm off, but there's my best answer right there. Okay, given that f of x equals x squared e to the x, what is the approximate value of f of 1.1? Use the equation of the tangent line to the graph of x equals 1. All right, so not really calculator necessary for this problem. At least I don't think it is. Oh, it is. I see the decimal points. Rats. Well, let's just use the calculator for the whole thing then. So the f of 1, that would be my y value. Well, that would just be 1 squared times e to the first, or just e. So we know in our tangent line, we're just going to have y equals x minus 1 plus e, which we're going to put as the decimal. And what we need is the slope, so we need the f prime of 1. And we're going to put that in the calculator. So x squared e to the x. This time when I do inderiv, I'm not going to do the y1. I'm just going to use the calculator. X squared e to the x. So alpha, window, number 3, in deriv, x, and we got x squared times e to the x, and we're finding the derivative when this is 1, and we're going to go 3 decimal places to get the slope. 8.155, rounding, 8.155, oops, 8.155, 8.155. And what is the approximation when we plug in 1.1? All right, well, 1.1 minus 1 would just be 0.1. So 8.155 times 0.1, just mean move one more number over, plus e. All right, so in my head I think it's just 0.81555 plus e. So really it's just at e. I don't know what those other things are. All right, back to the calculator. 8.155 times 0.1 plus e, and I'm going to use this one so I don't have to bother putting in an exponent. 3.534. 3.534. There we go, letter A. Let f be the function given by, and let g be the function given by at what value of x to the graph to the parallel tangent. So where their slopes equal. Parallel means same slope. So in this case, where is f prime equal to g prime? Well, let's find their derivatives. F prime, 3 times e to the 2x times 2. G prime, 18x to the second. So we're setting these equal to each other. I'm going to look at it on the graph. 6e to the 2x. We want to know where is it the same as 18x squared. All right. So, and look at these values. They're all between -1 and 0. So set your window appropriately on the calculator, because we're looking for the x value, right? Okay, so go to my calculator. 6e to the 2x, 18x squared. Y equals, clear that. So 6e to the 2x and 18x squared. I don't know why it has to jump down 2 places. 18x squared, and just set the window appropriately. When do they intersect? I don't know if the y values matter here. So -1, 0. They're going to intersect somewhere between -1 and 0 because we saw the values. I don't know if we have to necessarily see them. Let's go -10 and 10. This may or may not work. I don't know what the y values, and it's not important. I'm hoping we see them just from a standpoint of, okay, so you see them. So there's our answer. And second and trace is where all the fun things happen. Intersect is the 5th one. So 1, 2, 3. Negative 0.391. Negative 0.391. There we go, letter C. 17. Which of the following is the equation of the line tangent to the graph at the point where f prime is equal to 1? So set the slope equal to 1. All right, well, f prime, 4x to the third plus 4x. And where does this equal 1? So it's equal 1. Subtract 1 from both sides. If I'm going to solve this, it technically could have 3 answers. The degree is 3, and I want to find zeros, so I got to go to calculator, find the zeros of this. And then once I have that, I'll have the x value. Because we already have the slope, right? The slope is 1. And once we have the x value, we can then plug it back in and find the y value. All right, 4x to the third minus 4x minus 1. Back to the calculator. So clear that, clear that. So just deal with it. 4x to the wrong button. 4x to the third plus 4x minus 1. And we want to find the zeros. I'm just going to press zoom 6. There we go. So there's 1 0. I figured it only one real answer. The other ones would be imaginary. Find the 0. Okay, left bound, that looks good. Right bound, this time I'm just going to plug in the number 1 so I don't have to worry about it. So we have it surrounded. 0.237, so I'm writing that down. 0.237, wrong button. 0.237. So there's x, and we're going to plug that in. And again, the calculator should have that memorized if I can use it without messing it up. So with that, x to the fourth plus 2x squared. So again, it knows that x is that value. So if I go x to the fourth plus 2x squared. 0.115. 0.115. So writing the equation of a tangent line, we'd write y equals 1, x minus 0.237 plus 0.115. So we'd get 1x minus 0.237 plus 0.115. I guess it's that one. The difference between these. 237,115. We have decimals. 2, 2, 1. And it'd be a negative because that one's larger. There we go. Letter D. All right, consider the piecewise function. If a equals -3, b equals 4, will f of x be continuous at x equals 2? Justify your answer. All right, to be continuous, 3 things have to happen, right? The f of 2 must exist, and the limits as x approaches 2 from the negative side must be equal to the limit as x approaches 2 from the positive side. Okay, well, the f of 2 and the limit on the left side are going to be the same value, so it really just comes down to this. And a is -3 and b is 4, so I don't know why we wouldn't just fill this in. So -3x squared plus 4x plus 2. And -3x plus 4. And we plug in 2 into the top. And so this would be -3 times 4 plus 4 times 2 plus 2, -12 plus 8 plus 2, -2. And what do we get when we plug in? So that's the same, that's this limit right here, right? And so what do we get when we plug in 2 into the bottom function? This would be -3 times 2 plus 4, -6 plus 4, -2. So yes, will they be continuous at x equals 2? Yes, because the f of 2 equaled -2 and the limit as x approaches 2 of f of x equaled -2. There you go. Well, there we have it. The limit exists. Will it be differentiable? Okay, well, that means that we already know it's continuous, so we'll have to say something about it being continuous. Does the derivative exist? All right, well, f prime will equal -6x plus 4 and -3 when x is less than or equal to 2 and when x is greater than 2. And so really it just comes down to the limit. So does this limit exist? So to be differentiable, the limit as x approaches 2 from the negative side must be equal to the limit as x approaches 2 from the positive side. And 2 from the negative side would be -6 times -2, 2 plus 4. So that's a -12 plus 4 equals -8. And the other side is just the constant -3. So no. While f of x is continuous, or no, because while f of x is continuous, the limit as x approaches 2 of f prime of x does not exist. Now, what values will be both continuous and differentiable? At x equals 2. So now we're plugging in 2 into this function. So that would be 4a plus 2b plus 2. And this one would be 2a plus b, plugging in 2 for x. So to be continuous, then 4a plus 2b plus 2 has to be equal to 2a plus b. To be differentiable, then the derivatives have to be equal when x is 2. And let's see, the derivative of this one would be the top 2ax plus b. So if we plug in 2, that would just be 4a plus b. And the bottom, the derivative would just be a. So where is 4a plus b equal to a? Okay, so let's just put these both in standard form and do an elimination method. We have a system of equations, 2 equations, so we want to know where it's all going to come be equal to each other. So I'm subtracting 2a from both sides. I'm subtracting b, and then I'm going to subtract the 2. So we'll have 2a plus b is equal to -2. And here I'm just subtracting a. 3a plus b is equal to 0. And we want to know where these two equations come together. So 2a plus b is equal to -2. And I'm going to go ahead and multiply that by -1. -3a minus b is equal to 0. And add them up. We'll get -1a is equal to -2. If a were 2, and if a were 2, put this back into either equation. I'm putting it in here. That would be 6 plus b is equal to 0. B would have to be equal to -6. Just to confirm, if I put in 2 over here, 4 plus b is equal to -2. Yeah. So if a were 2 and b were equal to -6, say show work or justify answer, just show your work. All right, we showed it. There we go. And free response number 2. The rodeo performer spins a lasso in a circle perpendicular to the ground. The height from the ground of the knot measured in units of feet in the lasso is modeled by the function h of t equals -3 cosine, plus 5, where t is the time measured in seconds after the lasso begins to spin. Find the h of 0.75 using correct units. What is the value represented in context of the problem? The height, this would be the height of the lasso 0.75 seconds after it began to spin. So this would be measured in feet. All right. That's all it is. This would be correct units. So correct units would be feet, the height. All right, so got that function. I'm going to type it into my calculator. I'm going to put it on the graph so I can use it a few times over. All right, so y equals, oh, geez. I think I know the issue. I think my arm leans on the screen. Clear. All right. -3 cosine of 5 pi over 3 x plus 5. The domain has to be greater than 0, so for my window, it doesn't make any sense to have negative values there. And also doesn't make sense to have negative values here for y either, because the lasso can't go below the ground. We've all jumped rope. All right, so there's lasso. It's going up, going down, going up, going down. Trace, and if I just do 0.75, I'll have 7.121. There's our answer. So writing that down, 7.121 feet. There we go. Find the correct value. Now this is a change in h, which is feet, right? That's what it's change in y over change in x, change in time, so change in second. So this is going to be feet per second. This is how fast the lasso is going. I hope that makes sense. So at that, so so this is the height of the lasso at 0.75 seconds. And this is going to be the speed of the lasso at 0.75 seconds. That's what's coming. It's a rate of change, right? Maybe I should say the rate of change. So it could have a negative speed, could have a positive speed. But there we go. So maybe I should say velocity rather than speed. But I'm going to do the derivative of this. I'll just go in deriv here. We could do it on the other screen as well, but we can graph the derivative with it. Now, I can see it's going to be negative in some places. alpha trace lets me put in different equations. So it's a y2, and I'm going to do it for all values of x, which is just x, and graph. And this is going to be a negative value, but it's all right. And trace, and the end derivative is there, so 0.75. Now it was on its way down, so it should have a negative. Negative 11.107. Negative 11.107. This is the velocity. Because it's negative, it gives direction. So correct units. There we go. Sketch a graph of h prime. Okay, so let's make a table and we'll go 15 to negative 15. I don't need to make a table. I'm just going to sketch it off of the calculator here to the best of my ability. Changing my window. So that's fine. I just need to go to 5. It's counting by ones, so I'll keep the scale ones. And negative 15, positive 15. And if I wanted it to look just like that, and this is what I'm talking about, the scale right here, it's counting by 15, so I'll just make it 15. And you'll see it'll look just like it. You can go to my y equals, I'm turning off this graph, which means hit the equal, enter on that equal sign. So we're only going to graph the derivative, that's all it asks for. So there you go. You know, if I were going for pure accuracy here, I'd find those zeros and all these zeros along the way. And I can see the maximum minimum is, I think 15, I'm guessing, is what it is. So for time's sake, I'm not going to find them, but there's 1, 2, 3, 4, 5. It looks like 3 is an actual 0. I guess I can confirm that. Trace 3. Yeah, look at that. 3 is actually a 0. So good enough. But we have a 0 somewhere right in there. We got a 0 a little bit after 1. We got a 0 a little bit before 2. Or sorry, a little before 2, and a little after 2, and at 3, and before 4, and after 4, and before 5. And we hit a maximum between these places. So the last is going up, going down. Or the speed of the lasso, speeding up, slowing down, speeding up, slowing down, speeding up. All right, close enough. During the first 5 seconds of the performer spins the lasso, how many times is the lasso at its maximum height? Well, this is the derivative, so it'd be easier to answer from the other time. Give a reason for your answer based on the graph h prime of 0. Okay, well, let's use this graph that we're looking at here. Change the color. Anytime we're going for increasing to decreasing as a maximum. Increasing to decreasing. Remember this derivative. So decreasing to increase, this is a minimum. Maximum, minimum, increasing, and then decreasing, maximum, maximum. So there's 1, 2, 3, 4. And you can say it's at its minimum 1, 2, 3, 4. And we can confirm that with the other one. But how many times is the lasso its maximum height? 4. Give a reason because h prime changes from positive to negative 4 times. on the interval. One, two, three, four. All right. What is the height of the lasso the first time? What is the height of the lasso the first time it is at its minimum height on the interval of 0 to 5 seconds? Justify your answer. He didn't ask what the time was, but the first minimum occurs here. I was getting ready to say there, but no. And what's that height? So we could find that value, but it's just after 1 second, and it doesn't say justify your answer. I'll show your work. Okay, well, so where does h prime equal 0? And it's, I don't know how you can show your work on this one. I mean, I'm using a calculator. So it's that value right there is the minimum. Show the work on my calculator. Second trace, find the 0, and it happens between 1, we'll say 1.5. So left, well, why am I at right bound? Start again. Second trace, number 2, left bound is 1, and right bound we'll say is 1.5. We get surrounded, and we'll press enter, and at 1.2. So I guess they want us to write h prime of 1.2 is equal to 0. And so what is the h of 1.2 would be that height. So we'll just go back to that other graph, turn it on, and enter. Turn that other one off, graph it. So again, we changed it. There it is at 1.2. It's a minimum, right? And this is going to represent the height. So just trace 1.2. And it's at 2 feet. There we go. And I think that's it. All right, I'm just going to scroll through all the answers, so if somebody wanted to just come to the very end of the video, they could have it. Let me go back to the front page. You know what, I'll just post this as a slide.